This finite element analysis tutorial in Solidworks is about finding displacement and factor of safety for this beam and running this simulation on true scale as well. So let's begin. Click on part and click OK and go to features from here. Change the background to plain white, and after that click here and make sure that you are working in mmgs as units that are millimeters. Now select on front plane and click on sketch, and then select here midpoint line, and at this center create here a midpoint line like this. Now select this line and here make relation vertical just to make sure that this line is straight, and again select here midpoint line and create a midpoint line at the center again. Now again select this line, but this time assign relation horizontal. Now since I want these lines to be construction geometry, so select these lines one by one and make them as construction geometry. Now select line and make here a horizontal, vertical, inclined and vertical straight line. Press escape button now. Now let's define it. So select your smart dimensioning tool and then specify the length of this line as 37 and length of this line is 5 mm, and after that we will be defining the degree between these two lines by selecting these as 100 degree, and finally the distance between these 2 points as 10 mm, and after that specify the length of this vertical line as 50 mm. Okay. And now since we want the same sketch onto the other side, as you can see the sketch is fully defined as well, select here mirror entities. In this window we will be selecting all of these lines and we want to mirror it here. So in this mirror about window we will be selecting this reference center line to mirror it here, and as you can see this is mirrored now. And now I want to mirror the whole this sketch here, so I will select the mirror entities again, and in this mirror entities window I am selecting all of these lines, this one, and finally this one, and mirror about this horizontal center line. So that was basically the benefit of making these center lines. Check this box from here, and now you can see the sketch is fully defined. So go to features from here, select extruded boss base, and here define the length of extrusion, which is 800 mm. So here specify 800, and since I want the extrusion on both sides, so I am selecting here mid plane, and as you can see the material is on both sides. So check this box from here. This I-beam has been created, and now for the weight distribution and weight selection in analysis I am making some sketches. So make here a center rectangle on this face like this, and now let's specify the length of this line is 50 mm. Width of this line is the same as the previous. Now exit the sketch from here, and in features tab, as you can see this is features tab, we have curves. So in curves we have split line. We need to select here projection, and in this window we need to select this sketch, and in the next window we need to define the surface where we want to project it, and check this box from here. And now as you can see this area is separated, this basically surface is separated from the beam, and now I am selecting this back surface and click on sketch, and here select corner rectangle this time and simply make 2 corner rectangles here and here. Now select smart dimensioning tool, and here specify the length of this line as 50, and similarly for the other one as 50 mm, and simply exit the sketch. The sketch is fully defined. You can exit the sketch from here, and we are going to repeat the same procedure. Split line, in this window we need to select this sketch, both of these will get appeared, and in this window we need to select this back surface. So click on this back surface and click OK, and as you can see, the surface is now separated. When I click it, this is now highlighted as separate surface. So I will show you the benefit of this. Just click on add-ins, and here make sure that you have enabled SolidWorks Simulations, and after that click OK. When you enable it, go to Simulation tab and click on New Study. Here you need to select this static and click OK, because we are doing static structural analysis. Right click here on part, and here select Apply Material. So we will be applying material. You can apply anyone you like. So I'm selecting this one, the first one in this steel category, and click on apply and click on close. And as you can see, the color has been changed, which means that material has been applied. We are not applying connections because there is only one part. So here select fix geometry, and we will be fixing this back side. Let me show you this surface and this surface. Basically, this was the benefit of splitting this. The beam will be supported on these two surfaces like a bridge. Okay, now right click on external loads and click on force, and we will be applying the force on top surface at this specific area, this one which we have splitted. And here specify metric as units, and here specify how much weight you want to put on in kg. So I'm specifying as 1800 kilograms and click OK. Now right click here on, as you can see it, the load has been applied. Right click here on mesh and click on create mesh, and here you can specify the mesh size, which I am specifying as 18, which is very coarse, but it will run faster. When you make it finer, 2 millimeter, 1 millimeter, it will take more time, but it will give accurate results. And as you can see, this mesh has been applied. Okay, now you can simply run the study. So it will take some time. If the mesh size is more and the geometry is complex, this will take even more time. And now right click here on the displacement and click on show, then click on animate. Okay, let me make some changes in the model. So go to model, and here I want to add some fillets. So go to features and select here fillet, and select this surface, and here specify a radius as 4 millimeter. And after that I'm moving it fast and forward so that your time can be saved. Just select all of these edges, and 4 mm fillet is fine. Click OK. And after that we need to go to this simulation tab again and run this study again. Okay, now in displacement click on edit definition and go to this tab, and here select minimum and maximum. And as you can see, this is the minimum and maximum values, but these are not in floating. So select here, and rather than scientific we need floating. And as you can see now, these are not in 10 to raise power. And here select true scale in edit definition of the displacement. And now if you can right click on displacement and click on animate, and now as you can see, the displacement is very small. The displacement is very small because the factor of safety is definitely very large. So when we enable this factor of safety from here, and when you click here OK, and here you can see the factor of safety is 3.5, which means that this beam can handle 3.5 times more load than 1800 kilograms, because we have applied 1800 kilograms as load, and these are the values for the strain. And when you right click here on the displacement and click on edit definition, when you remove this true scale, click on automatic and click OK. Now if you right click here and click on animate, and now it will deform on exaggerated scale. So if you find this tutorial helpful, then please subscribe to my channel. Thanks for watching.